so now the frequency is 16 hertz, and we can see the first fundamental harmonic. Then if we increase the frequency to 32, so about here, we can see the second harmonic, and then we can go to, for example, 48, so that would be the third one.
A standing wave is not actually a wave, but rather a pattern of a wave. In fact, it does not consist of crests and troughs, but rather nodes and antinodes. In particular, we have analyzed the standing waves in the vibration of a string fixed both hands. The frequencies of these standing waves are called harmonics. The first harmonic is also called the fundamental harmonic. It has 2 nodes and 1 antinode. The nodes are the ends of the string, and the antinode is in the middle. The wavelength of a standing wave for any given harmonic is related to the length of the string. In this case, the length of the string is equal to the wavelength divided by 2, so the wavelength is equal to 2L. The frequency is equal to the speed divided by the wavelength, so the speed divided by 2L. Now we have the second harmonic. In this case, we have 3 nodes and 2 antinodes. Now the length is equal to 2 divided by 2 times the wavelength. So, L is equal to the wavelength. The frequency is now 2 times the speed divided by 2 times the wavelength, so the speed divided by the wavelength. The last harmonic that we have analyzed is the third harmonic. In this harmonic, we have 4 nodes and 3 antinodes. Here, the length is equal to 3 divided by 2 times the wavelength. So, the wavelength is equal to 2 divided by 3 times the length. The frequency is equal to the speed divided by the wavelength. So, now it's equal to 3 times the speed divided by 2L. In conclusion, we can see that the second harmonic is 2 times the first, the third harmonic is 3 times the first, and so on. So, the frequency in general is equal to n, that is a number, times the fundamental frequency. So, it's equal to n times the speed divided by 2L. And the wavelength is equal to the fundamental wavelength divided by n. So it's equal to 2L divided by n.
Okay, now we're using a mass of 50 grams as our tension. So the first fundamental harmonic is 9.6, and now we can find the second one and the third one. So we can predict that it's going to be a 19 point, I don't know, it's going to be 29.8.